Good morning, students. Jai Swaminarayan. In the last lecture, we have completed up to sum number 4 of exercise 13.2. Today, students, we are going to start from sum number 5. A die marked 1, 2, 3 in red and 4, 5, 6 in green is tossed. Okay, students. Sample space according to given is written as 1R, 2R, 3R. 3 faces are red and the other 3 faces are green. So we attach a suffix R and G so that we can understand. Event A denotes the number is even. Okay, students. Event A, the selected number is even. So the variables are 2R, 4G and 6G. So probability of event A is 3 by 6. So half. Event B, the number is red. Okay, students. Event B is equal to the selected number is red, and here the variables are 1R, 2R and 3R. So probability of event B is also 3 by 6, and that is 1 by 2, and A intersection B will be 2R. So probability of A intersection B will be 1 by 6. Students, here we are to check whether events A and B are independent or not. Now P of A into P of B will be 1 by 2 into 1 by 2, and that is 1 by 4. Therefore, P of A intersection B is not equal to P of A into P of B. Therefore, A and B are independent events. Therefore, events A and B are independent events or not, are not independent events. Sorry, students, I should have written A and B are not independent events. Because for independent event, students, we should have P of A intersection B equal to P of A into P of B. So here, students, sorry, by mistake I wrote independent. It should be not independent. Now, students, question 6 to 11 are all, you can say, objective type questions asked for 2 marks or asked as MCQ. And this is totally, students, based on, you can say, the list of formula. So one must perfectly memorize, understand this particular sums. Okay, question 6 to 11, which we are going to do today, students. Now, E and F are independent events. E and F are independent events, and E and F are any given event, such that P of E is 3 by 5 and P of F is 3 by 10 and P of E intersection F is 1 by 5. Okay, students, here we are to check whether events E and F are independent or not. Okay, and I am also noting down the 7th sum. For given events A and B, okay, so according to B1 we have P of A is equal to half and P of A union B is equal to 3 by 5 and P of B is equal to small p. Then find P for given two conditions. First part, A and B are mutually exclusive, and second part, A and B are independent. In both the cases, we have to find small p. Okay, students. Now, all of you please concentrate. In the sixth sum, we are given that P of E is 3 by 5, P of F is 3 by 10, and P of E intersection F is given as 1 by 5. We have to check whether events E and F are independent or not. So first let us operate P of E into P of F, which is 3 by 5 into 3 by 10. So this is 9 by 50. So P of E intersection F not equal to P of E into P of F. Therefore, E and F are not independent. So what I am telling students, this all sums from 6 to 11 students are based on, you can say, list of formula, and this type of questions are asked in MCQ or in section A of part B for 2 marks. Now students, in the 7th sum, we are given P of A, we are given P of B is equal to small p, we are given P of A or B is A union B is 3 by 5. We are given two different conditions in the sum, and for both the conditions, students, we are to find small p. Now, if A and B are mutually exclusive events, then students, P of A and B will be 0. Recall the definition of mutually exclusive events. For any two given events A and B of the same sample space, if A intersection B is equal to null set, then students, events A and B are mutually exclusive. And from the union formula, we can make P of A intersection B a subject of formula. So we get this. So on the very first day, the first part of the lecture, I have revised all the basic formulas. Addition law for two events, P of A union B is equal to P of A plus P of B minus P of A intersection B. Students, we can make subject of formula union and intersection. So we can make this formula. So half plus P is equal to 3 by 5. So P will be 3 by 5 minus half. So 1 by 10. So in the first part, where A and B are mutually exclusive, students, we got P as 0.1. Now for independent events A and B, we have P of A intersection B is equal to P of A to P of B. Students, revise the basic concepts of independent event and law of multiplication. For independent events A and B, the probability of occurrence of A is independent of B and vice versa. So P of A given B is only equal to P of A, and P of B given A is only equal to P of B. So again, P of A intersection B will be half plus P minus 3 by 5, and this is equal to half into P. P of A intersection B is this only. So P minus P by 2 will be equal to 3 by 5 minus 1 by 2, which is 1 by 10. P by 2. So P minus P by 2 is P by 2. So P by 2 is equal to 1 by 10. So This comes are once again I am telling asked as you can say objective type questions based on only list of formula, and list of formula is directly dependent on your fundamental understanding of concepts. So the more you understand the concept, students, you will enjoy this. Now, students, sum number 8 and 9 we are doing. A and B be independent events. Okay. Answer 9. A and B are independent events. P of A is 0.3. P of A is 0.3 and P of B is 0.4. Find the following. The first part is P of A and B. Okay, second part is P of A union B. Third part is P of A given B. And students, the fourth part is P of B given A. Never read as oblique. Always read, students, in terms of concept. Always understand, students, the fundamentals rather than simply reading this as oblique. Okay. So again, recall of the list of formula. If A and B are independent events, then P of A intersection B is equal to P of A into P of B. So 0.3 into 0.4, so this is 0.12. P of A union B is equal to P of A plus P of B minus P of A and B. So 0.3 plus 0.4 minus 0.12, so 0.70 minus 0.12, so 0.58. This is P of A intersection B upon P of B provided P of B not equal to 0. So 0.12 divided by 0.4. So this is 12 by 40. So 4 3s are and 4 10s are. And this is P of A intersection B upon P of A. So this is 0.12 divided by 0.30. So 12 divided by 30, 3 4s are and 3 10s are. Or you can alternatively write this as 0.3 and 0.4. Students, second half of the chapter has been removed, but the second half of the chapter which is removed from the syllabus is totally dependent on this first half of the chapter, where we study conditional probability, where we have law of multiplication and the formula for independent events. Okay, now, sorry students, this was sum number 8. Sorry, by mistake students, I wrote sum number 9. This is sum number 8. Now, sum number 9. A, B are any given events. Okay, so according to given, P of A is 1 by 4. P of B is 1 by 2. P of A intersection B is 1 by 8. Find probability of not A and not B. We have to find probability of not A and not B. This students we have to find. Now again, I am telling you, the list of formula comes into play. Not A means A dash, not B means B dash. So this is symbolically written as A dash intersection B dash and intersection. And students, or means union. This all of us know. Now, students, what is the next part? In the list of formula, as I told, on the very first day we have written this P of A dash intersection B dash is equal to P of A union B the whole dash. And students, this is equal to 1 minus P of A union B. Okay, now P of A union B will be equal to P of A plus P of B minus P of A intersection B. So this is 1 minus 1 by 4 plus 1 by 2 minus 1 by 8. So if I simplify by taking 8 as LCM, 2 plus 4 minus 1 on 8. So this is 1 minus 6 minus 1, 5 by 8. So this is 3 by 8. This is our answer. So this is again, students, based on the list of formula, and the main part of the sum is to understand the words in terms of the symbols. That is, you can say, the main part in terms of application of formulas. Okay, now we are doing question 10 and 11, students. Next is sum number 10 and 11. Now, here, students, pay attention. In the tens A and B are such events that P of A is half. Okay, answer 10. According to E, P of A is equal to 1 by 2. P of B is equal to 7 by 12. P of not A or B, not A or not B is half, is 1 by 4. Check whether independence, whether events A and B are independent. Okay, 11 symbols are noting down. What is E1? A and B are independent events such that P of A is equal to 0.3, P of B is equal to 0.6, A and B are independent events. Okay, students, based on this, we are told to find the first part is P of A and B. Second part is P of A and not B. Third part is P of A or B. And the fourth part is P of neither A nor B. Okay, students, this we have to find. Now, in this type of sum, students, in the first instant, check question number 10. Not A or not B. I am sorry, students, I am writing a little bit smaller handwriting, but this is my natural, you can say, habit, students. Please, you can say excuse me for that. Now, students, not A means A dash, or means union, and not B means B dash. So if I convert this to symbol, this is written as A dash union B dash is equal to 1/4. Now again, De Morgan's law comes into play. Again students, De Morgan's law comes into play. A dash union B dash is P of A intersection B the whole dash, and P of A intersection B the whole dash is 1 minus P of A intersection B, and therefore P of A intersection B is 1 minus 1/4, which is 3/4. And according to V1, P of A into P of B will be half into 7 by 12, so 7 by 24. Therefore, P of A intersection B not equal to P of A into P of B. Therefore, A and B are not independent events. This was what students we are supposed to find. So what I am telling students here, one must be very careful, one must be very, you can say, cautious in applying the appropriate formula. If you don't apply, students, the appropriate formula, you are bound to get wrong answer. Now sum number 11. A and B are independent events, so P of A and B is symbolically P of A intersection B, which is equal to P of A into P of B. So 0.3 into 0.6, so this is 0.18. So P of A and B is symbolically written as P of A intersection B, and if A and B students are independent events, then P of A intersection B will be equal to P of A into P of B. Now P of A and not B, and means intersection, not B means B complement, and this is equal to P of A into P of B dash. If A and B students are independent events, then A and B dash are independent, A dash and B are independent, and A dash and B dash are also independent. So this is 0.3 into 0.4, so this is 0.12. Now P of A or B is P of A union B, and that is P of A plus P of B minus P of A intersection B. So 0.9 minus 0.1 is 0.72. And last but not the least, neither A nor B means A dash intersection B dash. Symbolic conversion of P of neither A nor B students is P of A dash intersection B dash. I think students, if slightly this is not visible, you can easily understand. I don't think you should have any problem. A dash and B dash are also independent, so this is equal to P of A dash into P of B dash. So 0.7 into 0.4, so this is 0.2. Sorry students, if this much is not visible. This is 0.3 and P of B dash will be 0.4, so 0.12. And this is 0.9 minus 0.18, so this is 0.72. I think that easily students you can understand. Now, students, sum number 12. Question 12 is very interesting, students. And now, from this sum onwards, few questions, few long questions we have of independent events. Students, a dice is tossed 3 times. Find the probability of getting an odd number at least once. Now, probability of getting an odd number at least once means either once or twice or all 3 times. Now, answer 12. Sample space of rolling a fair dice is set of integers 1 to 6. So the total outcomes are 6. This much all of you can easily understand. Now, the probability of getting an odd number is same as the probability of getting an even number, and that is nothing but 3 by 6, because there are 3 odd and 3 even integers in set of integers 1 to 6. This much I think all of you can perfectly understand. Now, probability of getting an odd number at least once, we will do it in a different way. Suppose we do not get an odd number in any of the 3 tries, the probability of not getting an odd number in all 3 tries is half into half into half, because these all are independent events. In each one of the trial, the probability of not getting an odd number means getting an even number. It means getting an even number in all 3 trials is half into half into half, and that is 1 by 8. So if I subtract this from 1, then I get the probability of getting an odd number at least once will be 1 minus 1 by 8, and that is 7 by 8. So here, first of all, we found out the probability of not getting an odd number in all 3 tries. Means in all 3 tries we got an even number. If I subtract that from 1, I get the probability of getting an odd number at least once, which is 7 by 8. So this you have to understand. This is a long sum based on the concept of independent event students. Now, from 13th Sunday to the next lecture, let us answer the 2 MCQs. MCQ 17. The probability of getting an even prime number on each die when a pair of dice is rolled. Sample space of a pair of dice being rolled can be written as set of ordered pair xy, where x varies from 1 to 6 and y varies from 1 to 6. Total elementary outcomes of sample space can be written as 26. This all of you know since your 10th standard. This is known to you students since your 10th standard. Now, this is the property method of writing sample space. Now, event A, probability of getting an even prime number on each die. Event A getting an even prime number on each dice. Now, all of you know, even numbers as far as sample space of a dice is considered. Even numbers are 2, 4 and 6, and the first even prime is 2. So getting an even prime number on each dice has only one variable, and that is ordered by 2, 2. So probability of event A is 1 by 36. So the correct option is option D. So this is what, students, we have to do in the given MCQ. Now, MCQ 18. For independent events A and B, or events A and B will be independent if which of the following is true. Now, students, in the 18th MCQ, P of A dash B dash is understood as P of A dash intersection B dash. While doing law of multiplication, I have explained, students, that A intersection is written without sign. And if A and B are independent, then A dash and B dash are also independent. So this will be P of A dash into P of B dash, which is equal to 1 minus P of A into 1 minus P of B. So if A and B are independent, then A and B dash, A dash and B and A dash and B dash are independent. So if this is true, then A and B are independent events. So the correct option is option B, sorry, not C. The correct option is, students, option B. So this completes our exercise, means basics of exercise, students, 13.2. We will continue with the further long sums. Almost you can say the exercise is done, but the further long sums from 13 onwards we will complete in the next lecture. Okay, here we conclude the lecture. Write these sums twice. Memorize the list of formula, students, and do once sums without looking, so that you are able to understand which formula is to be applied according to the given condition. So, students, here we conclude the lecture. Next lecture we will complete 13.2. Only now 5 sums are remaining. Thank you, students. We will conclude the lecture.